Haskell.
So I'm Adam. I work for WellType these days, but I also have a past as a dependent type theorist, and I'm interested in things like constraint solving and type checking. So I want to tell you about an idea that's probably about an eighth baked at the moment. This is even less organised than anyone else's, but it's something I've been thinking about over the last couple of days and in a few conversations with people. I think you'll like the idea as well. So those of you who were at Christian's talk this morning will have noticed that he was using type-level natural numbers to check that the lengths of vectors were correct. And those are great, but there's a lot they can't do. So in particular, it might be nice if GHC knew that n plus n was n plus m. I know that Christian's got some work going on to be able to prove that inside GHC. It's great that with the new promotion features, we can promote NAT and we can promote plus. Richard does some very cool work there. But this isn't the computational definition of addition. This is some extra property that we'd like to be able to hold. Now, I'm interested in units of measure, being able to say that something is measured in meters per second, and if you multiply it by something measured in seconds, then you get a result in meters. And what that comes down to in the type system is proving this equation. So some unit g times some unit h is equal to some unit h times some unit g. And again, this is one of these equations that isn't just automatic. It doesn't fall out of the computational system that you've defined in the type language, but it's some extra property of the equation theory that you have. And we could go on. There are so many more of these different constraints that we'd like the type checker to solve for us. We'd really like to add features to GHC so that it can solve group equations, or it can solve equations with natural numbers, or it can have an SNT solve them. But how do we get that to work? Do we implement that inside GHC and wait for the next GHC release before we can use it? And that's what I'd like to not have to do. I'd like to be able to write something, a function of this type in a user program. So there's a bit more complexity you might want in the type, but the basic idea is during type checking, GHC will have some list of constraints that it can't solve because it doesn't know that n plus n equals n plus m. And maybe I can supply some code that generates that proof. So maybe I know that I'm working with the natural numbers and I'd like addition to be commutative. So I write this function, or something that looks rather less like it, because the type representations inside GHC will be slightly less clear than this. But the essential idea is I use the GHC API to deconstruct the constraint and supply a proof of it, which the type checker can then use. And so just like a core-to-core plugin allows you to write core-to-core transformations without modifying GHC itself. So this would allow you to modify the type checker without modifying GHC itself, and then we can really get the promise of this wonderful paper outside in X, modular type inference with local assumptions, which sets up this wonderful framework for doing type inference in a modular way where the equational theory X is up to you. Except in GHC there's one equational theory you get, and that's the one that's solved by the constraint solver it gives you. I'd like to be able to write my own constraint solver and fit it inside. Thank you very much.
So now we have a 10-minute break. See you in 10 minutes.